In this video I'm going to show you how to find the domains of some interesting functions. So here we have three given functions, and the question is about the domains of three new functions that are created by subtracting, dividing, and composing the original three functions. So first let's find the domain of each of the original function. So domain of f is all the x values except 4. So it can be written like this. The domain of g function is all the values of x that make x plus 1 strictly positive. So that means x has to be greater than -1. And domain of h is all the x values which make 2 minus x greater or equal to 0. So that means x is between -infinity and 2 including. So this is how we find the domains of simple functions, just by considering their constraints. Now, when it comes to finding the domain of a function created from the original two functions, we can either do it analytically by simply concluding that the domain of a new function is the intersection of the domains of the two original functions, and this works well for addition, subtraction, multiplication. So in this case, we can just find the intersection of the two domains, which is all the numbers except 4 and all the numbers from -1 to infinity. So the intersection will be from -1 to 4 and from 4 to infinity. Or we can simply write out the entire function and without simplifying anything, find its domain as if it was given to us this way. So the answer will be exactly the same. So one way or another, the domain is all the numbers from -1 to 4, excluding -1 and 4, and all the numbers from 4 to infinity. Now, when it comes to finding the domain of a quotient, we have to remember that the values still have to be in the domain of each function, but in addition, we have to exclude all the values that make the denominator equal to 0. So in our case, that means that we have to start off with the intersection of the two domains and then take all the solutions of this equation. So that means we just have to remove 2 from that domain. So the answer would be now all the numbers from -1 to 2, then from 2 to 4, and then from 4 to infinity. Now, we could have done it the other way. We could have started with function g, to find the domain of g over h. We can do it analytically by finding the intersection of domain of g, domain of h, and then removing all the values of x which make h equal to 0. So first let's solve this equation. So when is h of x equals to 0? So the solution of this equation is x equals 2. So now let's find the intersection of domain of g and domain of h. Domain of g is all the values from -1 to infinity, and domain of h is all the values from -infinity to 2. So the intersection is from -1 to 2, and from here I have to exclude the value that makes h equal to 0. Now the other way to find the same domain will be to just write g over h of x as a quotient and do not simplify anything. Consider all the restrictions, pretending like this was the way the function given to us. And of course it will give us the same answer. Last one. To find the domain of the composition of G and F, we have to make sure that x is in the domain of F, because essentially this is what we have. X goes into F, and then the output of F has to be in the domain of G. So the way we write it is, so let me remove this equal signs here. So the domain will be domain of F together with the set of all values of X, so that F of X is in the domain of G. So figuring out for which values of X F is in the domain of G, we have to set up the domain of G as an inequality or equation. So what does it mean to be in the domain of G? That means F of X is strictly greater than -1. So to solve this inequality, we have to solve this inequality. So we have to add 1. We have to find the common denominator. And we have to solve this rational inequality. So solution of this rational inequality can be easily determined by the sign chart. So it's positive, negative, positive. So the answer is from -infinity to 3, excluding, and from 4 to infinity. So this is what this set is made of. And now we have to find the intersection of this set and the domain of F. So domain of F is from -infinity to 4 and from 4 to infinity. So the intersection is -infinity to 3 and from 4 to infinity. Now alternatively, we could have just plug in F into G, and without simplifying anything, consider all the constraints. So that would of course give us the same exact answer.